I want to talk to you today not just about the problems that we've got necessarily with regards to how web apps have in the past been sort of boxed into one location or another. Because, do we have slides for, apologies. Do we have slides? Or the other slides? We'll come back to my, my debugging session in just a moment. I've done this all wrong, you see. All right. Oh, I see. I was on the wrong screen. Also, it's nice to see my coworkers actually watching and editing my presentation in real time. That's gonna make for some good times here. Can you hit the present button? Bingo. All right. So, wow, that's not focused in the right window. Yes. Hey, there we go. So I'm going to talk to you today about making web apps, Appy or Appy web apps or something along those lines. It's a really difficult kind of set of words to pack together because our expectations about what an application are kind of different to our expectations of the web. We expect that the web is going to get us the most reach possible. This is you'll see the new device lab out here today, which I know that Chris Wilson and other folks here have been putting together furiously. But the best thing about the device lab is that it shows you in one concrete place the enormous reach of the web. Not only have we been able to create a platform that gets you all the users from one producer's device or one set of manufacturers' devices or one operating system. We've created a platform that gives you access to pretty much every device that's been shipped in the world in the last decade. We have more users on Chrome. I was looking at the numbers. We have more users on Chrome than all iOS device shipments to date. That's not to say people using iOS devices. That's all iOS devices ever made. Think about that for a moment, and then think about how you invest in those two platforms differently and your expectations of them. And they're very different because the web, is, despite having enormous reach, is a little bit awkward. And that awkwardness is a big issue, not so much on the desktop, when getting to the stuff that's just there is really easy. It's up hanging in a tree. But in the mobile web, we've had a bit of a disconnect because the power that you get between being able to deploy your application to pretty much every user everywhere, and the ability for them to frictionlessly share it with everybody else, and the ability for those experiences to show up in indexes and crawls and make it possible for third parties to also help share the experience that you've built with other people for whom it might be relevant. That power doesn't really work well with the UI surface areas that we're all carrying around in our pockets. Access to the home screen, being able to be in the notification tray, all of those things are critical when typing something on a little tiny screen with a, even with a better keyboards that we've got now. Let's admit that's not sort of where we want to be. Someday we'll be able to talk to our phones and it'll always just work, but for now, we're only just there. And so saying a URL at a phone is usually a hilarious thing to do in public and a frustrating thing to do in private. I recommend you try both sometime. So we don't have access to a lot of these UI surface areas today. And it all gets back toward whether or not we're first class. Are we part of the ecosystem's top-level affordances or not? And if we are, being first class has real advantages. And so it's worth asking, what do we need to get there? What do we need to do to actually get ourselves to become first-class citizens in the most important operating systems that we're all using? So we've looked at this problem quite hard over the last couple of years. And we started by understanding that we all need to be building things that work offline. We all need to be building things that just work offline. And the definition here of work is a little different than you might imagine. I'm not asking you to build things that work offline in the sense that all the data is always cached up front and it was done by magic. No, I'm asking us to get to a place where we've got basic equivalence with the frustrating native apps on your phone that launch and then fail, right? It would be great if it was the application that's delivering the bad news about what just happened to the network, but maybe presenting you with the previous state, as opposed to a situation where you're looking at a blank white loading screen. The white loading screen is perhaps the worst part of the web experience today because we can't think about web applications as being trustworthy yet. So we need to give ourselves the ability to build offline that just works. And we need access to system UI. We've heard over and over and over again from you that access to placement in the home screen and the ability to build applications that you can alt-tab to is a critical differentiator. It's part of what it means to build an application versus build a website. And we've built up a whole series of stories and expectations around applications versus websites, premised, I think, on the inability to be part of that top-level affordance. Being in the tab switcher the natural way actually has real power, and I'm very excited about what's happened in Lollipop as a result. And I think we need faster and better access to powerful capabilities. There's a whole series of applications today that make a ton of sense on the web, and really not anywhere else, for lots of reasons. But there's a whole series of applications that you can't build. The application performance work that you're seeing out of the Silk team, and the work that's happening with Asm.js, and the ability to accelerate regular plain old websites and make them work very quickly is massive, but it doesn't necessarily open up access to new hardware and sensors and capabilities in a way that I think we all kind of want to see. We'd like to be able to keep the pace. We want portability, but we want to keep the pace. And that's a place where I'm hopeful that some of the things that we're going to show you today are a good down payment. So what would it be like to actually have a web app, an application that feels like an application, but comes from the web and can still be on the web? It's a little bit like a black swan. If you haven't seen it before, you might have not theorized that it could exist. And I'd like to submit that most of us haven't seen it before. Most of us have dealt with PhoneGap or Windows 8 or Chrome apps that have tried to give us applications in our native application ecosystem that are built with web technology. And I think I can speak for everyone who's a web developer here today and say that HTML, JavaScript, and CSS are not the best part of your day. And so someone coming to you and saying, hey, I've built a new system that will let you build applications with HTML and JavaScript and CSS is not perhaps the most exciting proposition that everyone's given you. If, however, they said to you, hey, I've made it possible for this indexable, linkable, searchable, easily shareable, friction-free application platform that we've delivered to you to work really well and as a first-class citizen when you want it to, I think that's compelling. I think that's a better story. And yes, HTML, JavaScript, and CSS are key enablers of that story, but they aren't the story. So we need to get back to a place where we can build something once, build it, and deploy it to the web without awkward packaging steps, without intermediate gatekeepers that add friction to the process of sharing something, and get to a place where an app, a real app, is also just a real website. We need to see these things in the wild before I think we'll collectively come to understand what they're going to be. So what would a good experience for this be like today? Like, let's just say that you took the set of things that the web is currently good at and the set of things that apps aren't particularly great at, and you looked hard at them and said, well, what part of my life could be made better? I was thinking about this question, and it occurred to me that it just happened to me. I was in New York for the Velocity conference a couple months ago, and it's a great conference. I got to talk about performance and service workers and all sorts of my favorite things. But after the conference the next day, I had a little bit of time before my flight, so I stopped into the Google New York office to hang out with some people who I don't get to see very frequently and whose projects I'm interested in. And so we got lunch, and we got to talking, and then I looked down, and I was late for my flight. OK. I did that. Nobody else did that to me. I did that to me. But I needed to get to JFK, and public transit was going to be like an hour and change. And if I took a cab and there wasn't any traffic, it might have been 45 minutes, and I could just make it. And then this happened. And this happened not just once inside of downtown and midtown. This happened basically all the way out to the airport. But luckily, I was stuck in one of New York's new taxis, which, despite having looked like an elongated Prius in the back, and maintaining the wonderful yellow color of New York taxis, which makes it easy to spot, has kept the quaint feature of New York taxis, wherein your knees are introduced to your face significantly before you even get on the airplane. I just think of like a warm-up for getting on the flight. It's nice to see that some things don't change. So I wasn't going to make this flight, basically. And I had I known that I was in real trouble, I could have downloaded an airline application that might have notified me that my flight, as I found out later, was delayed. That would have been great information. And in fact, I did find that out at some point in my hour-and-a-half trip to the airport in the back of a cab where I was studying the pattern of the jeans that I was looking at. And not having had this happen, not having it notify me, made me really stressed out. So I was calling my wife, and we were trying to figure out, like, oh, can we get another flight? It wasn't good. So when I found out that my flight was delayed, it was a breath of fresh air. It was like one of the best things that had happened to me in a long time because I got to go home. Now, I had used the airline's website, and the airline's website is actually incredibly full-featured. The airline's website, I already have a login to. Chrome has synchronized my passwords to that, so that's pretty good. So anywhere that I log into their website, I've got access to sort of all of my history, all of the stuff that I've done with them. But I use this website relatively infrequently. I use it whenever I want to travel, and hopefully that's not that often, or when I'm looking for flights. But it already knows all the state. So it's a little bit punitive to need to go to an application when the website could just do it. Now, I could have used their mobile website. And as you know, mobile airline websites are mostly just practical jokes. They're designed to give you the feature set that looks tantalizingly close to being what you want, but at a different URL, so none of the other stuff actually works. So it got me thinking, what would it be like to actually have an airline website that did just sort of work? So if we can show.
You're on the OMA?
Yeah, I think we're good. Great. Do we have video from the? Bingo, great. So what would it be like to actually have sort of a modern web site for a modern airline? So this is Polymer Air, and Polymer Air is built with beautiful polymer components. There actually aren't that many of them. This was relatively straightforward to put together. And I can do all the stuff that you'd expect to do on an airline. And this is the exact same website as the desktop website. It scales up and down. It uses responsive design using the Polymer responsive design components that's just sort of baked in. And this is a great system. So I can come in here and imagine that I want to, when I check in, let's see, 1, 2, 3, 4. Okay, I was going to check in, and my last name is Russell Still. Yes, I can spell my name. Mostly. Okay, so let's say I'm going from San Francisco to London, and I'd like to know when I check in about updates to my flight. No, I really would like to know when I check in if there are updates to my flight. By the way, you're looking at a very, very fresh build. This is the inadvisable live demo. Oh, sad panda. We'll come back to this in just a moment. So the mobile website for really this wasn't meant to be nail biting. Yes, the inadvisable live demo. So let me show you some other stuff that does work. Can we go back to the? Great. So in today's Chrome dev channel, we can build web apps like Jake, our beautiful and wonderful moderators, trained to Thrill demo, that work offline. So this is a web app that Jake has built, and I'll show you more about it later. But let's say that we're somewhere in San Francisco where Wi-Fi and network connections are at the home of Silicon Valley, where getting Wi-Fi is a pain in the butt, are just like that. This site still works, right? In fact, I can go and I'm going to swipe it away, kill that, and we'll come back to Chrome Dev. And this site is still working. I'm in airline mode. The site absolutely works. And so I can get back to the status that I had. So let's say I go back online. And like any good application, it's telling me what the status of the network is. It doesn't actually know. That's the thing about being offline. You don't really know if you're offline or not. It would be nice to know in a definitive way, but the only way you can really know is by checking in your application to know if you are. So when I refresh stuff now, I'll see the updated content. But notice that this thing didn't stop showing me anything, and it didn't give me a blank white loading page. It showed me exactly what it knew about the state of the world, and that caused us to be able to show the user, say, for instance, their boarding pass if we were an airline, if we had an airline website that worked. Just going to go with that. So in the poly-error system, what we really want is the website to be able to come back to us and tell us that our flight was delayed. It would be wonderful if when we register for a push message, and then at some point later, and our flight happens to be delayed, it was the website that told us, because I'm not going to be sitting here with this website open. It would be best if, in fact, the website decided to tell us, while we were doing something else. I think that would be pretty swell. And in fact, what we're looking at here today is a build of Chrome that has push and notifications and works offline. And it's told me, and I probably was actually going to notice that happened because it showed up on my watch. And in fact, if I come back to that, come on, Android, no, really? Yeah. If I come back to that and I swipe that away, we'll see that the status is swiped away here too. This is a real native notification. All right, back to the safe waters of Chrome Dev. That's a real thing. That's a real thing that I think most of us want. We want the ability to re-engage users where they are. And in fact, we also want the ability to take applications like this and sort of save them all the way to the home screen. Darren alluded to earlier what we're going to be doing to make it easier for you to add stuff to the home screen. But when you do, it sure would be great if these things showed up at the top level, and when you tapped on them, if they came back as full-screen applications that didn't require a URL bar when you didn't necessarily need one. And when they show up in your taskbar, they should show up as themselves. They shouldn't show up as just another web tab. This is all stuff that we're delivering today, and I'm going to show you how this works. But this works, and you can do it too. So hooray. Can we go back to the Chromebook? Do I need to do that?
I got it.
All right. Sorry. By the way, I've done the live demo thing exactly the way that everybody who knows what they're doing would tell you not to do it, which is not just to have a dependency on the network and not just to have one device that you're demoing, but to have multiple devices and then have those devices not be the ones that are plugged into the video screen. So if you find yourself doing a live demo, I suggest that you take tips from me and not do it the way I'm doing it. Do you know where?
Yeah. It got lost.
Got lost, I see. Yeah, so I think the most important part of that demo isn't that we built a website that works offline. That's something that we've been able to do for a little bit. The most important part of that demo is that we built a website that works offline occasionally. We built a website that I didn't have to interact with a lot, or I didn't have to repackage. I built it in the natural way, and then I was able to add the offline capability to it at some point later. As I'll show you in just a moment, service workers enable you to build web applications that, service workers enable you to build web applications that you can upgrade with offline capability if you build them the right way. So the most important part of building your application the right way is, do we have the Chromebook back? Or the slides? Yeah, great, here we go. So the most important part of building your application the right way, and I apologize for the jank here, is that you build a real web application. So let's see, I want to build a new tab, and I'm going to go to polyair.appspot.com, which is where this demo was hosted, and you can try it out today. And if you're using Chrome Dev today, all of the offline capabilities should work for you, and they will work for you in beta soon. So this is a regular website, right? This is not something that I built just for mobile. This is not a separate code base. It deployed like a website, and in fact, I didn't have to package up my resources in a new and unique and potentially very special and not the best ways kind of way. This is something that I use infrequently, but I want to get back to it easily. And on the desktop, that's easy to do because I've got a URL bar and I've got a search system there, and it's really easy to use. But typing queries into a phone is not the best way to do it. But I want to be top level here too. So I'm just going to close that up, and I'm going to come back to this application, which I've saved to my desktop. We're going to start asking users to whether or not they want you to be able to save this to the desktop. But today, you're able to do this manually. But in the very near future, users, if you build your applications the right way, will get asked by us whether or not sites that they interact with frequently, that are built using service workers, and that have the right metadata, want to be treated like applications. And this thing is a real application. We want it to be a real application. And what you'll notice here is that the top-level UI is different. There's no URL bar here, but I can see what the URL is. And in fact, the Chrome Dev Summit site is built the same way. This is also a site that has a service worker, will work offline for you, and is built to be a standalone application, which means that I can alt-tab between them the way I've always wanted to between my web apps. It's not lost in the sea of tabs. It's its own standalone thing. This is the sort of power that I think you really want when you're trying to become that black swan, a website that actually finally is an app. What does it mean to be top level? Well, not only are you in the bar there, you're over here. You're in the app launcher. You're where users are looking to get back to their stuff. You're part of the easy recall mechanisms that are built into operating systems. You're part of the tab switcher. Your icons are the right thing in the right place all the time. Great. So let's talk about how we did that. Can we go back to the other slides? Yeah.
Are you coming back to this?
Yes. Great, thank you. Meticulously rehearsed and flawlessly performed. So that was just the web. I think the key thing to take away from what we have just seen is that what you were looking at was a website, right? You deployed it the same way. It has URLs. All of the states inside of that site are URLs. You didn't have to package it. You didn't have to build a separate application container. You didn't put it in a store, not even the Chrome Web Store. You built a website, and then it turned into an application because the user chose to turn it into an application. It's a thing that they thought was valuable to them and wanted to keep, not a thing that you thought might be valuable to them and wanted to push, right? This is the key to doing engagement well, I think. But let's figure out how we actually pulled that off. There's three components to this. The first is a service worker. You're going to need a service worker for everything I show you, and pretty much all the new capabilities that we're going to add to the platform in the future. So you're going to need that. Manifests, which eventually will point at service workers, and the push notification API was a part of this. The push notification API isn't shipping when service workers initially launch later this year in Chrome 40, but it will be coming soon. And some of the details of the code I'm going to show you work today and work in the poly-air repository, but those will be changing, and so stay tuned for those updates. But let's talk about offline. Offline happens, and when offline happens, and you know that it's offline, you're kind of bummed out, but it's nice to know. The worst part is when you don't know. Because the very worst kind of offline isn't offline, it's sort of kind of online. And so I lived in London during the 2012 Olympics. And so as a wired modern city, London decided that it was going to put Wi-Fi in all of the tube stations. You heard that right? The stations. So what that means, of course, for those of you who are laughing, that you already got this, is that you can be in the station waiting for your train, start loading a web page or something else, step into the train, and be moving 2 minutes later to the next station. Meanwhile, TCP has dropped out. It just doesn't know it yet. It's got a 2-minute window. So you're sitting there watching maybe a white spinner or a blank page trying to load, and then you get to the next station, where your phone is furiously trying to reconnect to the same network, which was made available in that station too. And maybe it's busy, or maybe you don't get on it, or maybe you get on it, and then you try to tap things. But you know, London's a modern city. Those doors close quickly, and you're on your way again. You can play this dance most of the way to Heathrow, by the way, from central London. You can maybe try to load the same news article, which with 700 kilobytes of JavaScript at the top, which are loaded off the network and not out of the cache, is not my favorite dance. So enter the service worker. The service worker is a programmable in-browser proxy that lets you decide what to do. Not the first time you visit a web page, but maybe the second, third, and fourth times that a user visits a web page after you've decided to install yourself. The service worker has control over the cache, and it has the ability to mediate pretty much all conversations with the network. In the past, we've attempted to solve the offline problem. By solve the offline problem, I mean we've been trying for a very long time. Who remembers Google Gears? Wow, your scars are as big as mine. All right, so Google Gears gave you a programmable gave you an in-browser ability to cache files. It was called local server, but it wasn't a server and it wasn't programmable. It gave you a list of files that you could put in, and it would dutifully hold on to them for you. We also implemented app cache, which allowed you to give us a list of files, which we would download and then dutifully give them back to you. But we also didn't let you program it. And so having not solved the offline problem twice for you now, we've decided to do something cheeky and not solve it. Instead, we're going to let you solve it. We're giving you actually control over how this whole process works. So how do you get started? How do you get out of the gates? So this is the registration code for a service worker. A couple of things to note about it. First, the script that you're registering here has to be on the same origin. And that origin has to be an SSL origin. Service workers don't work over insecure connections for lots of boring reasons, but the exciting reasons are that it's 2014. Holy cow, get some SSL. What you'll see here is that it returns a promise. And that promise means that the installation process is asynchronous. This code is going to run in the background. The service worker process actually goes through a series of phases once the browser encounters your request to register and install the service worker. So the browser downloads sw.js, and when it succeeds, it'll hand you back a registration object, and you can find out some things about it. The scope object there tells you basically which path in the origin that your service worker is now registered for. And at the root, that's going to be the root. But that's more of an advanced feature that you probably don't need to worry about. Once you're inside the service worker, your code is going to be run from top to bottom. So the first phase is the install phase. The install phase is an event like any other DOM event that you might be familiar with, and you can control the lifetime of this event and say, I'm not actually ready and I'm not actually installed. Don't count me as being installed until this promise resolves. So you pass a promise into wait until, and then it goes. If you don't do anything here, if you don't have an event handler for it, you'll be considered to be installed straight out of the gates. Note that you can also add items to a cache. Now, I said that we had tried to solve this problem for you multiple times before by giving you the ability to generate a very long list of things and then put them in a cache. It turns out you probably want to do that. It also turns out that you probably don't want to have just one cache. We learned this the hard way multiple times, and we apologize profusely for it. But we're giving you the ability to add lots and lots of caches and control them and version them independently, but you have to do that. And this is the sort of code that you're going to be writing to get that done. So you can add a list of resources to a particular cache, but also notice that this API is incredibly promise heavy. If you aren't familiar with promises, Jake, once again, has written a great article about how to use them and what to expect. But we partially designed the promise API in JavaScript and in the web platform to support service workers. So it should be no surprise that you're going to see it used all over the place. It's also possible to import third-party libraries, your own libraries, obviously. And there is going to be, in the initial release of service workers in Chrome 40, you're going to want the service worker cache polyfill. It'll add a couple of extra methods to the caches. But caches are available natively in the first release of service workers later this year. But these scripts are going to be cached along with the service worker script. When you download sw.js, the browser is going to go fetch these resources and cache them together. They come down as a package, basically. And in fact, this is how you can do collaboration with third-party scripts. You can use import scripts, which is an existing API inside of web workers. And you can call out to third-party CDNs or third-party resources and use those inside of your service worker. This is a great way to collaborate. And you have programmatic control over requests. You can handle fetches. And in fact, you can handle fetches multiple times. So let's say you pull in maybe a third-party plus service worker snippet using import scripts, and it wants to handle only requests for plus.google.com. It can do that, but you can also handle the main requests for your resources using multiple event listeners. So this is pretty good. And you'll note the return of respond with. It's often the case that you don't know exactly what you're going to want to do in response to a request that comes to your service worker. That's OK. You have some time to do it, but you have to tell us that you're going to need or have to take time to go get that work done. The reason for this is that service workers can be killed at any time, basically. Whenever the service worker script is quiescent, whenever it's not doing any work, we reserve the right uniformly and unilaterally to shut it down. And in fact, we're going to do that aggressively. We're doing this to preserve users' batteries and ensure that the memory usage of service workers is low in the common case. But the side effect here is that you need to not be keeping global state inside of your service worker. If you are, it's going to get killed and you're going to be surprised. The good news is that the dev tools simulate this quite accurately today. You can be happily going along debugging a service worker and it'll die out from underneath you. Not the best debugging experience, but at least it gives you a sense for the lifetime. This is a simple pass-through proxy. There's a new fetch API inside of service workers. It's the XHR that you've always wanted. You're welcome. It returns promises, and it takes a request as the key. You send in a request, and it hands you back a response object. Also, response and request objects. Hey, wouldn't it be great if we had those as opposed to manually packing those in on a per library basis? We've added that too. There are some batteries included, but just enough to let you do your own thing. So this is the simplest read-through proxy you can imagine. You could do something like this to, say, get real user metrics in terms of runtime performance. Obviously, the navigation timing and resource timing APIs give you a lot of that today. But if you want to do something specific and custom, here's a great place to do it. It's also the case that you can construct your own responses, as you see at the bottom here. We're looking at an event handler at the bottom that creates a new response object, passes in the content of that resource, and sets status and headers, and then responds with it programmatically. You can imagine doing client-side templating. You can imagine doing your own parsing and processing of responses that come back from the network. All this stuff is possible with service workers, and it's relatively straightforward. I am incredibly excited to see what you do with it. I'm also a little bit fearful, but incredibly excited. All right. So remember that cache that we populated earlier? It's possible to get an individual cache object out of the caches collection, but you can also match globally against a single request. And matching globally against a single request allows you to take the first thing that comes back. This is a nice, easy-to-use way of saying, if you have something in any of the caches that matches this request, hand it back to me. But again, it's asynchronous. The match operation returns a promise, and when you get it back, if it's in the cache, you'll get an object, and if it's not in the cache, you'll get null or undefined. And that is to say that in promise speak, something not being in storage isn't the same thing as an actual exception. You will need to handle exceptions separately here. So let's talk about what happens if I populated a cache, but my application comes through and it needs something that it doesn't already have. This is read-through caching. It's a little bit simplified from what you're actually going to want to do. But basically, you can fetch it if you don't already have it, and then you can put it back in the cache and then respond with it. This is really straightforward inside of the Service Worker API once you sort of wrap your head around promises. But aside from that, you have all of the power to do all of the things that you wanted to do at runtime. You didn't have to be omniscient. You didn't have to be omnipresent with all the developers in your team. You can actually sort of clean up some of their errors in this sort of situation and do things for them to make sure that caches are actually populated. So let's talk about performance for just a minute. This is a slide from Ilya Grigoryk's talk at Velocity last year. And it talks about the lifetime of the 1 second budget that we'd like to give ourselves if we're actually going to do the right thing by users. 1 second is a long time. You know, it's a very, very, very long time when you think about how fast CPUs are and how many operations we can actually get done. But from a user, 1 second is really where you start to get annoyed. 1 second is a bad place to be if you're not giving something back. And on the web today, and specifically the mobile web, you can blow out that 1 second budget very easily. And in fact, if the radio's dead and you're in a cold sleep state on a phone, you can blow out that 1 second budget just starting the radio. You'll never have a chance. You'll never be able to get out of the gates. You won't even be able to look up DNS in that 1 second if you're on a 3G connection and you're in a deep sleep state at the network level. So remember that you may already be behind your 1 second goal, and then you have to add an RTT for DNS if you don't already have it in the cache or it has expired, an RTT for TCP setup, an RTT for HTTPS setup, or an RTT or 5, and then HTTP request and response setup. This is pretty bad. This is to get any bytes on screen if you're going to the network for those bytes. This is a very bad place to be. And this is the place that we're all trying to live in. By the way, you have done a heroic job in trying to get your mobile websites to load fast. But the deck has been stacked against you. This is a bad place to be, and we need to do better. So this is, again, Jake's Train to Thrill. And this is a side-by-side comparison of it loading the very first time, and then it loading with the service worker. The first time is on the left, and the service worker is on the right. What you're looking at is those bytes were on screen immediately in the service worker case. And that experience on the left-hand side isn't great, but the right-hand side experience is what happens every single time you come back to the application after the first time. Isn't that better? Isn't that what we all want out of the web that we're interacting with and the applications that we interact with? I think so. All right, so let's talk about how, as you're starting to build your site with a service worker, you're going to make sense of what's actually happening. All right, can we go back to not the phone, but the Pixel? Great. Bingo, thank you. So one of the things that we have added in, let's say I'm going to add USB debugging here. One of the things that we've added to Chrome in recent years, are we displaying the? Great. One of the things we've added to Chrome in recent years, which is huge for debugging on mobile, is Chrome Inspect, Chrome://inspect. And that will show you things like all the pages that you're currently looking at, and will let you inspect them immediately. But today, it also is going to allow you to inspect service workers. So these are the local service workers that I'm looking at. The Chrome Dev Summit site is going to work offline, and it's got a service worker. And we can inspect it in the normal way. It's just DevTools. That's pretty great. And we can do the same thing for the Polyair service worker. And you can see that this is a service worker. It's got a global scope. It's got a bunch of stuff we've added. But it's actually a very small object compared to what you get in a document. So this is a much smaller API than what you see in the DOM. But IndexedDB is available as storage, not local storage. And you have the ability to work with it in the normal way. But the interesting part comes when you start to work with devices. So let's go back here, and let's look at my Nexus. Because the DevTools team has done such an outstanding job, it's possible, when this works, to both see what I'm looking at on the phone and to start debugging it. So I can drive this here, right? Cool. And I can go to the service worker internals page of the device itself. So Chrome. Service worker internals is going to work both. What? Oh, I missed a colon. Maybe I missed a colon. Maybe I need to load it from the device. Bug to be filed. All right. I can see the registration status. I can see that there's a service worker that's been activated, but stopped, which means that it was loaded, and it's now active for a particular bit of the origin space, but it's been killed by the browser because it isn't doing any useful work. If I go back, for instance, to train to thrill, we'll see that the service worker state here goes to something else. Just one moment. New tab, train to thrill. Now if I come back here, we'll see that all the logs are being sent to the activated and running service worker at the middle there. So you can see the logging status that's coming off of it. And this story is going to get better for debugging service workers. But you have the ability both to inspect them here, but also to connect to them over the USB debugging bridge. So that's pretty great. All right, can we go back to slides? Sorry. Thanks. OK, so that's inspecting and debugging. It's worth noting that an application that feels like an application, that does the sort of stuff that we've just seen, has to be composed of two parts. The first is a shell. It's the thing that boots up when you initially tap on the icon or go to the URL. And the second part is content, which you probably want to send down in the initial payload when you're first loading your application. But subsequently, you really want to be composing content into the shell. If I navigate from place to place, I don't want a full page transition necessarily, and so I want to be pulling content and loading it in with Ajax. Building an application in the modern style using something like Polymer makes this trivial. The Polyair application is really just that. It's data binding plus a bit of content shell, and when things change in my data, things change in my UI. This is a really natural way to do it, and I can start to do synchronization on top of a data model. And this is how we need to start thinking about constructing applications. Jake's Train to Thrill is perhaps the most elegant and futuristic version of this because it has server-side logic for smooshing down the initial payload the first time you go to it, then installing a service worker, and then subsequently launching the shell, and then feeding it data. And that's sort of where we really want to be, where we're launching something almost instantly. So today, to get ourselves onto the home screen, you sort of have to do this dance, where you click on Add to Home Screen, you add something there, and then it shows up like this. Again, if you build your site with a service worker and a manifest, and it's high quality, and users like it, and they come back to it frequently, you're going to start to see us asking users whether or not they want to continue to engage with your site in this way without necessarily having to determine in some inscrutable menu and without any actual context whether or not this is something that they want to do. We're going to make this better for you, and we know that this is our job. So what is that metadata? Today, this is that metadata. This is from the Chrome Dev Summit site, and I had to snip a little bit. You have to do this on every page, every single page, at the top of the page. And by the way, those are very valuable bytes. Let's say a user is coming to your site for the very first time. This sucks. This is bad. This is in your first couple of packets. This is stuff that you wanted to use to put pixels on screen to tell the user that something else was going to happen, or give them the answer in the best case scenario. This regurgitation over and over and over again, which is subtle and breaks easily, is a bad thing. And so we're replacing that with a new web manifest format that's being specified at the W3C in conjunction with Mozilla and others. But what you do instead of that long-winded thing at the top is instead to put your theme color, if you want one, but a link to a manifest. And that link to a manifest is something that you can point to from any document in your origin. And it's going to include all the stuff that you really want, but it can be extended with other stuff later. So for instance, you'll see at the bottom there is GCM sender ID. That's what we need in our demo application to make it possible for the notification API to understand, or the push notification API to understand where you're actually coming from with regards to the back end of the push system. We hope not to need this in the future, but for now it's extensible, and we expect to start to use this for more and more features that don't fit anywhere else in the platform. High-resolution icons, a long description, a location to load when you initially tap on the document in your launcher. Those are all part of the manifest, and you can even control the screen orientation. This is good stuff, and we expect that this is going to be a key enabler for making it possible to build things that feel appy. All right, let's get to the push notification bit, because I think that was the bit that you actually clapped for. OK, I don't know if that was tension because I did it wrong, or so. So what you're seeing here again is promises being used nearly everywhere. This is a little method that we've put together to request permission to do notifications. This is an existing API that we're extending for this new world. And so because it doesn't already come with promises, we're wrapping it in a promise. And again, you can create your own promises. And this is sort of how you can control inside the service worker things like delaying activation or waiting on some network or IndexedDB response for data. But we're going to request permission, and then if it's granted, we're going to vend a promise that resolves successfully with it. And I'm not going to deal at all with how to do those permission prompts correctly. My colleague Adrian is going to talk to you all about how to do that and how not to do that. And I can only say that if you do it right, it's going to work out well for you, and if you do it badly, you're going to have a bad time. So let's say that we get to the point where we've got that request. So we can request it, and then, as you see here, request, and then we can say navigator.push.register. This registration method is going to move to a different location in the API, and I'll update the appropriate things as that happens. But basically, you get a registration, and then you can send the registration ID that you get back as a part of that registration object to your server, so that your server can send things to the backhaul push messaging system and then notify you on your device. That's what allowed us to deliver a message to Chrome, even though Chrome was dead. Chrome was listening for the message that you sent, even though Chrome hadn't been started when I received that push message. So that's how we enable end-to-end push message registration. All right, on the service worker side, so by the way, there are some push notification systems that you may have used in the past which don't let you start your application when you receive a notification or a push message. That's a pretty bad user experience when, let's say, I am in the tube, and it's going from hop to hop, and I've gotten just enough to know that something happened, and then I tap on it, and then it doesn't know anything about it. Instead, what we're doing here is we're allowing you to handle the push message and then create a notification yourself. Knowing that what you're probably going to want to do is take that data and put it in a database and make it available for your application when it starts back up again offline. There's nothing more frustrating than seeing a notification that has everything that you wanted to see and then going to an application and then telling you that it doesn't have it. We should do better than this, and our model allows that. So the way you do it is that you get data back from the event for the push message, and you can create a notification. The service worker true thing may change in the future, but basically, you can create a notification from the background context if you have previously requested it from the foreground context. You're not able to make that request for permission from inside the service worker, so make sure you do that in your application from the pages that you're looking at. That makes sense, though, right? The user's looking at your app. You should be requesting permission to do things from inside your app. All right. And in fact, you get events back to handle the stuff that just comes down the wire, or when the notification is interacted with. This is a natural outcome of the fact that the service worker could be killed between when you sent the notification and when it came back to you. So it's a good thing to use the notification object that comes back from the notification click to go handle things. Yeah. And I wanted to just let you know that while all of this, I think, is compelling and I think is going to enable you to deliver amazing applications in the very near future, we're just getting warmed up. Darren mentioned background synchronization, and it's a high priority for us in the near future. We know that you want to be able to go update your application when you're connected to power and a network and maybe the user's asleep. We know that you want alarms. We know that you should be able to make an alarm clock application on the web. We understand that. And we're working hard to make sure that those sorts of things are available in the future. And this is just a down payment. So we're listening. The slide deck will be made available, as they all will. Jake's Is Service Worker Ready Yet website is the authoritative place to look for information about the status of the various APIs that are being added, and to understand how it's progressing in different browsers. So we're not the only ones who are implementing. We've designed this system in collaboration with our friends at Mozilla and others, and Samsung, and we're excited that they're implementing too. So thank you so much for your time and attention, and I'm excited to talk with you about how we're going to make real web apps.